let's consider the additive group of real numbers. That's a nice topological group. And let's now create a funny copy of that group in the following way. So we take the real numbers and we define a new addition by mapping the numbers we want to add first with some function f. Here's the graph of this function f. Adding the results and then mapping back with this f. This f is actually its own inverse, as we can easily see from the graph. So it's just the identity, but then we have flipped this interval here in a funny way. Okay, so G1 and G2 are isomorphic as groups, and F is the isomorphism. So if we look at, say, f of x plus y, the group operation of G2, and what do we get? By definition, here we have one more f on the outside. So we have f of x plus f of y. So this is just the definition, and then we have this additional f here on the outside. But the two outer f's cancel because f is its own inverse, and we get f of x plus f of y. So they are isomorphic as groups, but this isomorphism, as we can see here, is not continuous. So they are not isomorphic as topological groups. Let's see, this creates some funny topological properties for this G2, although it's as a group it's isomorphic to G1. Let's see. The identity is still 0. The number 0 is the identity in G2. Because what would we have to check? So we have to look at f of 0 plus f of x, but f of 0 is 0. So we have f of x, which is just x. Now, what about inverses? I claim that the inverse of x is f of minus f of x. So let's check if that is true. What is x, then u plus f of minus f of x? Well, that's f of, and now we have to insert f of the first argument, ordinary plus f of the second argument. So how many do I have to close here? Is that right? Maybe. So this x went here, Hoppla, here, and this f of minus f of x, that went here. Now these two outer f's here cancel again. So this is just minus f of x. And now we have a 0 inside this last f, and f of 0 is just 0. So we have the inverses. And now let's look at inverses close to 1, where we have this discontinuity up here. So what happens here? Let's calculate, well, let's take some epsilon positive, and then let's look at 1 minus epsilon and the inverse of that. So that's f of minus f of 1 minus epsilon. and that's just f of, well, 1 minus epsilon. There we are to the left of this discontinuity here. So the f is just the identity. So we get minus 1 plus epsilon. And close to minus 1, the f is also just the identity, so the inverse is minus 1 plus epsilon. Now let's take a point that's nearby 1 plus epsilon and calculate its inverse. Now we get f of minus f of 1 plus epsilon. But now we are here to the right of this discontinuity. So we are somewhere up here, and we have to use the 3 minus x here for calculating f of 1 plus epsilon. So what's that? It's f of minus, and now we have 3 minus 1 plus epsilon. Okay, so that's f of what? There is 3 minus 1, that's 2, and there's a minus sign in front of it, so it's a minus 2. And then we have 2 minuses and an epsilon, so it's minus 2 plus epsilon. Close to minus 2, f is just the identity, so we have minus 2 plus epsilon. And the standard topology on R, these are by no means close to each other. So we have two groups here, additive groups of real number, additive group of real numbers. We have, these are isomorphic as groups, but not as topological groups.